Hi and welcome back. This is Trigonometry Examples Part 2. We're going to be going through some more complicated of the word problems now, things that require more than one step in order to solve. And hopefully by the end of this, you will feel a lot more comfortable solving these more complicated word problems. So let's jump in to start with the first one. We have an apartment building, so I'm going to draw that right away. Grab a pen. There's my apartment building. From the roof, that should be an F, from the roof of the building. So I'm standing up here. You need to know your point of reference. And I've got a cell phone tower standing over here somewhere. Cell phone transmission tower. And it says the angle of elevation or angle of depression to the base. Remember, angle of depression is looking down, but you have to be looking out and down. So looking straight out and down, and then looking straight out and up at the top for the angle of elevation. And it says the depression angle is 65 and the elevation angle is 32. And you know that the building you're standing on is 250 meters from the cell phone tower, so that's 250 goes here. They want the height of the tower to the nearest meter. Well, if you look at this, you can see that I can figure out the height of the tower in two pieces. I can get that and I can get that, but I can't get the whole thing all at once. So this is going to require a couple steps in order to solve. I want this part and I want this part. Let's just give them letters so we can talk about them easier. If I do this bottom triangle, I know the adjacent side. And I know the opposite, I want the opposite side, and I know the angle is here. So adjacent with opposite, SOHCAHTOA tells me that I need tangent for that. So the tangent of my angle, remember it has to be together with an angle. You can't just write tan. You have to write tan of something. Equals opposite, which is x, over adjacent, which is 250. Multiply both sides by 250. And then you use your calculator. 250 times the tangent of 65. And we get 536.126, so 0.1. And our units are meters. So that's the first piece. I'll switch colors and we'll do the top triangle. So for the top triangle, again, I'm looking for the opposite and I have the adjacent. So once again, we're using tangent, but my angle is 32 degrees this time. Opposite is y over 250. Multiply both sides by 250. And then use my calculator. 250 times the tangent of 32 is 156.21, so 0.2 meters. So then I finish it off. 536.1, 156.2, 3296. So the tower is 692.3 meters tall. Always finish off a word problem with a sentence. This is type 1 in what I call type 1 of the solving questions, where you have to add to get the final answer. Let's have a look at another question, which is set up like this. The diagram is partially done for you. It says we got a hot air balloon at an altitude of 450. So it's flying at 450 feet high. Passenger sees two buildings. There they are, building 1 and building 2. Directly to his left, so he's looking at us and these are on his left. and uses a clinometer to measure the angles of depression to be 35 and 52. So how far apart are the two buildings? So I'm looking for this measurement right here. How far apart are those two buildings? And I've got two angles to use to do it. And they're both angles of depression. That means I need to draw in the imaginary horizontal line out here because your angles of depression are always measured from the horizontal. So the first angle of depression is this one, which is 35. And the second one is this one, the bigger one, 52. At this point, I'm hoping you can see that there's two different triangles that are being formed. I'll color code them to make them easier to see. You've got this one, and you've got this one. And you need to solve both of these triangles in order to get the solution for this question. Scroll down to give us some room. So let's go for the pink one first. In this question, we know the height of this triangle is 450, same as this one would be 450, because that's the height of the balloon. We're looking for the distance horizontally that these two buildings are apart. So I'm going to need this distance in order to figure it out. And I probably shouldn't use X. I should use a letter we haven't used yet. Let's call it Y. So in the pink triangle, I'm using the 52 angle because that's my bigger angle. The 450 is opposite. The Y is my adjacent. Opposite adjacent makes tangent of 52 equals opposite 450 divided by Y. So that means that I have to multiply by Y and divide by tan. So Y equals 450 over tan 52. And then I just use my calculator. 50 divided by tan 52. Again, you should be making sure that your calculator's in degree mode. 351.57, so 0.6 feet. Okay, then we have to go have a look at the green triangle. The green triangle is the 35-degree angle. This is my opposite. And Z is the distance clear across the whole thing. So let's call it Z. So that would be my adjacent. So again, I'm using tan. You're going to find that you use the tangent a lot for word problems. Not always, but you do use it a lot. 450 over Z. Multiply by Z, divide by tan to get that isolated. $450 divided by tangent 35. It's 0.66, so 0.7 feet. Now, you have essentially this situation where you know this length is 642.7 and you know this length is 351.6 and we want to know that length. So this is the second type of question where you have to subtract. When you have triangles that are sort of standing inside each other like this, you're going to be subtracting usually to find your final answer. And if the triangles are standing on top of each other, you're probably going to be adding. So in order to do this, I have to subtract those two numbers. So 642.7 subtract 351.6, and that leaves us with 2 291.1. So the buildings are 291.1 meters apart. Here's the next example we're going to work on. We've got a lighthouse on the edge of a cliff near the ocean. From the boat, which is located 250 meters from the base of the cliff, the angle of elevation to the top of the cliff is 20 degrees, and the angle to the top of the lighthouse is 30 degrees. What's the height of the lighthouse? So take a minute, pause the video, see if you can draw the picture to get it accurately done, and then I will draw the picture out for you, and you can see how well you did. Okay, so you should have had a lighthouse on the top of a cliff. This is the beam of light. You've got a boat that is 250 meters from the base, feet from the base of the cliff. Then they look up the angle of elevation to the bottom of the lighthouse and the angle of elevation to the top of the lighthouse. You can see how this is setting up very similarly to the question we just finished. To the top of the lighthouse is 20, to the top is 30. So I've got two triangles here, a 20-degree triangle and a 30-degree triangle. So I'm going to be finding this height, and I'm going to be finding this height. So I'm hoping you see that the triangles are inside each other, so I'm going to have to end up subtracting at the end. So this one is going to use tangent as well. The tangent of 20 degrees is equal to the opposite side x over the adjacent side 250. So x is going to be 250 tan 20. And I use my calculator to figure that out. 250 times the tangent of 20 degrees gives me 90.99, so 91.0, 90.99. There. 91.0 for x. Then I need to do the big triangle, the 30-degree triangle, the taller one. So again, that's going to be tangent again. Y over 250. So 250 tan 30 equals y. 250 times the tangent of 30. 144.33, so 144.3. I need this distance in between the two to get the height of the lighthouse, so I'm going to have to subtract. So 3, 3, 14, 50. So the lighthouse is 53.3 feet tall. One final question for you to work on. From the top of a cliff, so we got another cliff, 140 meters tall. An observer sees two boats, one directly behind the other, heading for shore. The angle of depression to the farthest one is 36, and the angle of depression to the closer boat is 47. Calculate the distance between the boats. So take a minute, try to draw the situation out and get the numbers on your diagram, and then I will show you what the diagram should look like. Okay, so hopefully you had a diagram something like this, where you've got two boats out here. This is your water. And you've got your person, whoever, standing up here looking out over the water. And you've got an angle of depression of 36 and an angle of depression of 47. So you can extend that line out to make your triangle. So this is the 36 triangle, and it's 140 meters tall. So again, I'm looking for this. I want to know the length of that triangle. So it's going to be tangent of 36 degrees, opposite over adjacent, which is x. Flip places with these two because I multiply by x and divide by tan. So x will be 140 over the tangent of 36, or 140 divided by tan 36, 192.69, so 0.7. If I create a triangle for the second boat, it's going to be here, using the 47, and this side would be y, still 140 meters tall. So the tangent of 47 is 140 over y. So y equals 140 over the tan of 47. And if you're wondering why these seem to switch places like they have been, I discussed that in part 1 of the video, so you can have a look back at that to see why it ends up switching places. 140 divided by the tangent of 47. 130.55, so 0.6. Always make sure you're rounding off properly. Now, this question is asking for the distance between the two ships, how far apart the two boats are. So this is a subtracting question. You know the whole distance, you know part of the distance, what's the piece in between? So 192.7 minus 130.6, so 62.1. So that's a quick introduction or review of how to do the multi-step word problems. You either have an addition type, which is the first question we did, or you have subtraction type, which is the last 3 that we did. So I'm hoping that that helps you feel a little more comfortable with this type of word problem. You will have some of these on your assignment. If you have any other questions, please contact me in the AC classroom, and I can go over a few things with you there. Bye for now.